right, today we're going to look at section 2.4, and 2.4 is a really huge section, so we're going to spend 2 weeks on it, on just one section. So today we're calling it 2.4.0 because we're really not going to take any derivatives today. All we are going to do is learn how to simplify, because sometimes after you take the derivative, what you have left is so crazy big that you have to know how to simplify it in order to get that final correct answer at the end. Okay, so these first three we're going to look at, again, no derivatives at all. We are just going to simplify. Okay, so when I look at this first one, you have to know what to do with that negative exponent, because in calculus at the very end, you can have fractions as an exponent, but they all have to be positive, so no negative exponents anywhere. Okay, so here, at the very end now, we're going to simplify this. So when I write my answers, I am very deliberate about what goes in the numerator and what goes in the denominator. Don't try to squeeze it in all on one line, because it gets really confusing to figure out where you're putting things. All right, so in this one, I'm going to make that big line here. I know 2 is going to be on the top. I know 21 x cubed is going to be on the top. 3 is on the bottom. This whole term here, because of the negative exponent, that's going to move to the bottom. And now we just have to simplify that. Well, I could say, well, 3 goes into 21 7 times. So that answer then is going to end up being 14x to the third. And on the bottom is 4x squared minus 5 to the 3/4. And then you can just leave it like that. All right, this one, same thing. I'm going to rewrite it, but I'm going to make it deliberate about what's in the top and what's in the bottom. Well, this 2x plus 1 to the negative 1/2, when it moves to the bottom, it becomes positive. And I already had a 2x plus 1 to the 3/2. Well, now you just have to know your algebra rules. If you have like bases, you add the exponents. So 1/2 and 3/2 is 4/2, and 4/2 is just 2. So my final answer is negative 5 over 2x plus 1 to the second. All right, this guy here, again, I have a 3 on the top. I'm going to have that negative 10x squared on the top. 5 is on the bottom. And this term moves to the bottom, and I'm going to make it a positive exponent. Once I get to this point, now I can just simplify. Again, I could say 5 goes into 10 2 times. So then 3 times negative 2, I have a negative 6x squared over 4x minus 1 to the third. All right, that is the top part of the worksheet, those three. We're going to look at the next 5 quickly for this part 1. Again, 4 through 8, you are not taking any derivatives. No derivatives at all. We are just simplifying. All right, so number 4, we have x to the 5th minus x to the 3rd. A huge part of simplifying is taking out the GCF and then simplifying from there. So if I take out an x to the 5th minus x to the 3rd, and I take out a GCF of an x to the 3rd, I am left with that x squared, and then x cubed out of x cubed leaves me with that minus 1. That is all you have to do on that one. So that's kind of a quick one, and we can move on. All right, number 5 is kind of the beginning of some really weird ones that you have. X to the negative 1/2 plus x to the positive 1/2. All right, here's the trick. When you have an x to the 5th and an x to the 3rd, you always take out the lowest of the two numbers. So if I have a 5 and a 3, I took out the 3, because 3 is lower than 5. Okay, same thing here. I have a negative 1/2 and I have a positive 1/2. Out of a negative 1/2 and a positive 1/2, which number is smaller? Well, the negative 1/2. So that's the one you're always going to take out. So I'm going to take out a negative 1/2. Well, what do I have left over then? Well, if I take out an x to the negative 1/2 out of an x to the negative 1/2, well, that's just going to leave me with a 1. Then, here's where people sometimes get stuck. If I take a negative 1/2 out of a positive 1/2, I kind of think of it a little bit backwards, is that I know that if I distribute it like this, I have to get back to my original. So x to the negative 1/2 times 1 is x to the negative 1/2. X to the negative 1/2 times whatever has to get me x to the positive 1/2. So I'm going to put an x in here. Now we're going to add our exponents because we have like bases. So what does this exponent have to be so that if I take negative 1/2 plus this exponent, I get a positive 1/2? Well, the answer has to be a 1. Because again, if I distribute this back, negative 1/2 plus 1 gets me a positive 1/2. So then I got that. So factoring out that negative is kind of a big deal that you understand this. And we're going to get to a bunch more like this. But when you take out the negative, chances are what you have left is that same base to that first power. Okay, now we have to simplify this because we can't have a negative exponent. So I'm going to rewrite it 1 plus x to the first goes on the top. This simply moves to the bottom. Again, I'm very deliberate with what's in the numerators and what's in the denominators. All right, number 6. All right, so I consider 3 different types of problems. One that's really straightforward on what I could factor out, one where I have a negative exponent, and one where I have a fraction. So they're all kind of solved a little differently. When I have a fraction, I want to make sure every term has a fraction. Well, here, this one's got the fraction, this one doesn't. So I want everything to have a common denominator. I'm going to rewrite this then to be 1/3 x to the 5th plus 6/3. Because 6/3 and 2 are equivalent, and now I have a common denominator. Because now I could factor out a 1/3. And if I factor out a 1/3, that leaves me with an x to the 5th plus 6. And then we can even write that a little bit more clearly, x to the 5th plus 6 all over 3. All right, so we got, just factor out the common term, factor out a negative, get a common denominator, and then factor that out. All right, we got 2 more for this part on the back. All right, so this problem, number 7, is kind of like when you factor by grouping, and we've already grouped it together. Now we just have to finish it off. So I think of this as 2 parts. I got this big part, and I have that part. So I have those 2 rectangles there. So now I'm really looking for what's the same in both rectangles. Well, I could take out an x plus 2, and in fact, I could take out an x plus 2 squared, taking out the lower of the 2 exponents. So then what do I have left over? Well, in this box, I have a 4x, and I still have an x plus 2. In the second box, I just have a minus 3. Well, now I don't have any negative exponents. I don't have any fractions. So now I'm just going to clean up that bracket there. So my final answer is going to be x plus 2 squared. Here, if I distribute, I get 4x squared. Distribute again, I get 8x. And then I have that minus 3. I do not need you to distribute. I don't need you to FOIL anything. Just clean up what's inside those brackets, and then you could be done. All right, last one here, number 8. 4y squared. All right, again, I'm thinking of it as 2 separate terms. There's one term. There's the other term. So now when I look at it, they both have a y plus 1. And in fact, I could do that y plus 1 squared because that's my lowest exponent. But they also have the 2 that I could take out. And they all have a y that I could take out. So out of both rectangles, I could take out a 2, a y, and a y plus 1 squared. So now I'm going to see what I have left over. Well, if I take out a 2y out of a 4y squared, that leaves me with 2y. That leaves me with y plus 1 squared. And then over here, it looks like I just have a plus 1. You are always going to have to clean up what the leftover pieces are. So I am going to have to clean that up there. So I'm going to have 2y, y plus 1 squared, 2y. I'm going to FOIL that. And now I'm going to distribute that 2y. And then there's nothing else I can combine, So that whole kind of crazy long answer, that is your final answer. All right, so that's it for part 1. I'm going to come back in a minute and we're going to do 9, 10, and 11.